All right, solving rational equations level 3. So notice here, I have two fractions and this one's not a fraction, so I could just leave that one there as it is, or I could just put over 1, but I won't. It's not required. Okay, so notice here, I have x plus 3 as my only denominator, so I'm going to go ahead and multiply each one here by x plus 3. So I'm going to multiply this side here by x plus 3, and you can put it on the left or on the right, wherever you have space, okay? So I'm multiplying each side by x plus 3. And I don't need to put parentheses around it. It's not necessary. Okay. So notice here, right on the first one, since there's no fraction to cancel out the denominator here, then we just multiply x times x plus 3, right? But we'll do that after we cancel these out. So notice here, x plus 3's cancel here, and x plus 3's cancel out there. So we are left with just numerators. So right here, notice here, x times x plus 3, I'll just do it again right here. X times x plus 3 is going to be x squared plus 3x. Okay, so that's what I get from the first one here. Minus what? Minus, and then we're just left with the x here. So minus x equals, and then equals 3. Okay, so notice here, no more fractions, just all one one equation without fractions. So let's combine like terms here. I notice here the 3x minus x is on the same side, so I could just rewrite that as x squared plus 3x minus 1x, that's going to be 2x equals 3. And then subtract 3 on both sides, set it equal to 0. That cancels out. I end up with x squared plus 2x minus 3 equals 0. Okay? And now here what we're going to do is we're going to go ahead and factor this. So all these are going to have to be factored, okay? And it looks like they'll all work out too. So x times x is x squared. And then I have a negative 3 here, but I also need a positive 2. So this is going to be a 3 times 1. That'll give me 3, but I need a negative 3. So let's make the 1 negative. So when I subtract, I get a positive 2. So this will be plus 3 minus 1, okay? Now from these two, I get two solutions, right? So I get the x equals negative 3, because that's what would make this factor 0 if I were to plug in a negative 3 there. And what this one will give me x equals positive 1. So notice I have two solutions here, but let's check for extraneous solutions. Let's see if any of these would make our denominator 0. If it does make our denominator 0, then we must reject that answer, okay? So again, we have two answers. And so let's see if any of these will make our denominator 0 in the original equation. So notice here we have x plus 3. And so if I plug in a negative 3 there, we know that negative 3 plus 3 will make it a 0. So we must reject the x minus 3 solution. That one is considered an extraneous solution. That means it has to be rejected. 1, on the other hand, if we do 1 plus 3, that gives us 4. We're fine. That's good. So looks like we have two solutions. One of them is extraneous and the other one is a true solution. Okay, and that's it. Let's keep going. Over here we have only one denominator and two non-fractions. So it looks like I'm only going to have to multiply by x plus 6 everywhere. So x plus 6, x plus 6, and then over here again, x plus 6. Notice here, these cancel out, the x plus 6's. And then everywhere else I have to distribute, right? So x times x is x squared plus 6x, right? Plus, now notice here I have 2x plus 5. The x plus 6 is canceled, so I am left with just 2x plus 5 equals, now right here distribute. 2 times x is 2x, and 2 times 6 is 12. Okay? Alright, we have a lot of like terms here to combine here, so let's see. 6x plus 2x is 8x, so it'll be x squared plus 8x plus 5 equals 2x plus 12. Okay, so let's set this equal to 0. Let's subtract 2x on both sides and subtract 12 on both sides. So our goal is to get 0 on the right side here and bring everything to the left. So we get x squared plus 6x, and then 12 minus 5 is 7. Minus 7 equals 0. Okay, and so let's factor this. And remember, we're going to have to check for extraneous solutions after we get our two solutions. So we have x times x for x squared. And then we need a negative 7 when I multiply. So that's just going to be 7 times 1. but I need a positive 6. So let's make the 1 negative again. So it's going to be plus 7 minus 1. Okay, so my two solutions are going to be here x equals negative 7 and x equals positive 1. Okay, let's see if any of these make this 0 in the denominator. So negative 7 plus 6, we're good. That gives us negative 1, no problem. And then 6 plus 1 is 7. We're fine. So both of these are good. Both of these are good. Okay, no extraneous solutions on this one. 2 more to go. Notice here our denominator is x minus 5, and so we're going to multiply by x minus 5 all the way across. X minus 5, x minus 5. Let's cancel out the denominators there with their numerator that we multiplied by, and so over here we end up with x squared minus 5x, right, when I distribute x times x and x times negative 5, minus 7 equals x. Okay, and so then we have to subtract x on both sides, and so that's going to cancel on the right, and then I get x squared minus 6x minus 7 equals 0. And then let's factor. So we get x times x, and then negative 7 again. So it's going to be 7 times 1, but I need a negative 6 this time, so I'll make the 7 negative. So x minus 7 and x plus 1. So we get x equals 7 and then x equals negative 1. Okay, again, checking to see if it makes the denominator 0. Neither of these do. 7 minus 5 is 2. And then negative 1 minus 5 is negative 6. So we're fine there. Okay, it's only when plugging it in gives us a 0 in the denominator that we have an extraneous solution. Otherwise, they're both good. All right, last problem here. So notice our denominator is x plus 7. No other denominator here. So we're just going to multiply by x plus 7 all the way across. Okay, so x plus 7 and then x plus 7 there. Okay, so notice these cancel out, the x plus 7s. Everywhere else, we're going to have to distribute the x plus 7. So x times x is x squared plus 7x. Now notice here, because we have minus and then we have a binomial here, we're going to have to distribute a negative 1 there, okay? So this will be minus 3x, and then negative 1 times 5 is going to be minus 5, okay? So keep that in mind. If you just write 3x plus 5, you're going to get it wrong because this has to be distributed, the negative, okay? And so over here, we end up with 7x plus 49. All right, so let's combine like terms there. So we get x squared plus 4x minus 5 equals 7x plus 49. Subtract 7x and subtract 49. Everything cancels out on the right. We end up with x squared minus 3x minus 54 equals 0. So 49 plus 5 is 54, but they're both negative, okay? So now let's factor this here. We end up with x times x for x squared, and 9 times 6 is 54, right? So let's do negative 54. And then we want to do 9 times 6 because we want a negative 3 there, right? So we need to make the 9 negative. So x minus 9 and then x plus 6. Okay, so my two solutions are going to be x equals negative 9. Oops, not negative 9, positive 9, right? It's the opposite of that. And then x equals negative 6. Okay, now checking here on the denominator, we only need to make sure it's not negative 7, and neither of these are that. So that means both of these numbers are good.